Hello everybody. This video is going to teach you about graphs of linear inequalities. A linear inequality is just like an equation except the equal sign is replaced with a less than or equal to, a greater than or equal to sign. The solution, unlike an equation, a solution is any point that falls on the line. Here, a solution is any ordered pair that when substituted into the inequality would produce a true statement, because it's actually going to be a whole slew of possibilities. It's going to be one side of the line, a region. For example, here I have 2 points, 0, 1, and 4, negative 2, and I want to know if they're solutions to 2x minus 3y is less than 6. Well, what you would do is you would take this inequality, 2x minus 3y is less than 6, and you're going to substitute this point in to this inequality. Remember, this is your x and this is your y. So I have 2 times 0 minus 3 times 1 should be less than 6 if this is a solution. This first term is 0, and then I end up with negative 3 is less than 6. This is true, so yes, this is a solution to this inequality. For the next one, 2x minus 3y is less than 6, and I have 4 and negative 2. So I have 2 times 4 minus 3 times a negative 2 less than 6. And this turns out to be 8 plus 6, because the double negatives, is less than 6. And this is 14 is less than 6. This is not true. So no, this is not a solution to the inequality. So again, you just substitute the numbers in the x and the y, and if you end up with a true statement, it is a solution. If not, it is not. Let's talk about graphing. You may have graphed inequalities on a number line. Now what we're going to do is graph them on the regular coordinate grid. So for graphing, what you want to do is graph it as though it were an equation, except you want to use a dashed line if it's a less than or greater than sign, and then use a solid line if it's a less than or equal to or a greater than or equal to. Because what this means is the line itself is not a solution, but anything on one side of it would be. These mean that the line is a solution, but also one of the sides, anything in the one side would be a solution. Then what you're going to do is you're going to pick a test point, and you're going to put the point into the inequality. It's going to be on one side of your line. You pick whatever side. If you end up with a true statement, then that side contains all of the solutions, and you're going to shade that side. Okay? If not, if it's a false statement, you'll shade the other side. So it's best to show this with an example. Here I have an example. Y is less than x plus 4. And a little review here, a little points, that you have to do. 1, 2, and 3. Excuse me. So first we have to draw the line. If this was y equals mx plus b, and we were thinking of it as a slope of a line, we would say slope is 1, and our b, our intercept, is 4. So what we would do is we would start at 4, and we would graph our slope then, up 1 over 1, up 1 over 1, up 1 over 1. We could also go down 1, back 1, down 1, back 1, down 1, back 1, down 1, back 1. Now the inequality sign is less than, which means that this line that I draw has to be a dashed line, like this. Okay? Like that. And now what I'm going to do is pick a test point. In other words, I want to pick a point that's either over here or a point that's over here on either side of the line, and I want to put that x and y coordinate and see if it's a solution. I always use 0, 0 if I can. As long as the line doesn't go through there, I can use 0, 0. And you'll see why in a minute. I'll put 0 in for y, 0 for x. There's absolutely no math to do here. 0 is less than 4. This is true, which means that all of my solutions lie on the side where I put my test point. So what I'm going to do is just shade this side. In other words, any number or any point that's in this region would satisfy this inequality. Now, what you may notice, and this could help you when you're picking your test point, notice it's a less than sign, and all of the shaded area is pointing down towards negative numbers, which is less than. Okay, that might actually help you when it comes to graphing. All right, next, I have y is equal to a negative 3x. So again, if I want to graph this, m is going to be negative 3. Now I could say this is negative 3 over 1, or I could say it's 3 over negative 1. My intercept is not there, but it's the same thing as having plus 0. In other words, this one's going to go through the origin. So now what I'm going to do is I'm going to use both this one. I'm going to use this first. So that means I go up 3 and back 1, up 3 and back 1. This other one says go down 3 into the right 1. So I'm going to go down 3 into the right 1, down 3 into the right 1. Now again, it's a greater than symbol. It's not a greater than or equal to, so the solutions cannot be on the line. So I'm going to draw a dashed line like this. Now, look at this. This is saying y is greater than. So if you think about it, what numbers are in the greater than region? Up here, it's pointing towards positive numbers. So I bet you that's going to be the shaded side. Watch, I'm going to pick my next favorite. I can't pick 0, 0 because the line goes through it. So my next favorite point is 1, 1 because that makes the math easy too. So if I take that in here, 1 is greater than negative 3 times 1. I get 1 is greater than negative 3. This is true, and sure enough, this is where my solutions lie. Those lines, those shaded lines I drew are pointing in a greater than direction. All right, next, y is greater than or equal to 2/3 x minus 5. You know, I can't write 2/3 very nice with the font, so I'm going to just rewrite this inequality. First of all, my b value is negative 5, and my m is 2/3. So I'm going to go to negative 5, make a point, and then my slope is up 2 and to the right 3, up 2 to the right 3, up 2 to the right 3, up 2 to the right 3. Now, when I fill this one in, it's going to be a solid line because this is a greater than or equal to. So I'm going to draw a solid line because solutions can be on this line, but they're also going to be in a shaded region. And again, a greater than, what side points to positive or greater numbers? I bet it's going to be this way. But let's just check it. All right, so I pick a test point. I could use 0, 0 because my line doesn't go through it. 0 is greater than or equal to, that's an arrow, there we go, is greater than or equal to 2/3 times 0 minus 5. Now you see where this 0, 0 is great because I don't have any math to do. This first term gets wiped out, leaving just negative 5. 0 is greater than negative 5, which means yes, my solutions are over here. And it's just like I kind of predicted from the sign. All right, let's try another sample, shall we? Uh-oh, this one looks different. Well, this one, what you're going to have to do is you're going to have to solve this for y. Think about it as putting it in a slope-intercept form. So what I want you to do is I want you to pause the video and try doing this one on your own, okay? Pause the video. All right, first thing you should have done, subtract 4x from both sides. This leaves 3y on the left is less than, now these are not like terms, so I'm going to write them separately. I cannot combine them. Okay? Now what I'm going to have to do is divide by 3, and I'm going to do that in every term. And y is less than, I have a negative 4/3 x. Remember that x could just drop down, minus 4. So my b value is negative 4, and my slope is negative 4/3. So I'm going to start here by going to negative 4, where my intercept is. And remember, I could say I want to go up 4 and to the left 3, or I can go down 4 and to the right 3. But considering my point is already pretty low on my graph, I'm going to choose to go up. So up 4 to the left 3. Up 4 to the left 3. Now, if you look at this one, it's a less than, so I'm going to make a dashed line like this. And think about where numbers, if I were to draw a shaded region, this goes to positive numbers, so that would be a greater than. It's probably going to be down here, I bet. But we'll know for sure if we pick that wonderful point 0, 0. I'm going to put in 0, and now I'm going to use the original inequality. 4 times 0 plus 3 times 0 is less than negative 12. And I get 0 here, 0 here. I get 0 is less than negative 12. And this is a false statement, which means that 0, 0 is not a solution. And sure enough, I'm going to shade this side. And that's what I thought anyway, because it said less than, or my symbol was less than, and that's shading a side that is less than. Okay? Now, this next one, really, really careful, okay? This is a very tricky thing, and you need to make sure you have a special note of what's happening here. So I'm going to say careful, like this, careful. Because we're going to solve just like before. Follow along with this. But something huge is going to be different here with this problem. Okay, greater than, again, these are not like terms, so I'm going to just do this. And now I'm going to divide, but what I'm dividing by is the key. Anytime when you're solving and you multiply or divide both sides by a negative number, something very interesting happens. The inequality sign flips over. So now this becomes 3 over 2x, and it's going to be minus 1. So again, that inequality sign flips over. Now some of you are saying, well, why? It doesn't make sense. I'm going to explain to you why, okay? If I gave you a true statement here, 4 is greater than 0, you know that's true. And now we're going to multiply both sides by 2. So I'm going to multiply this by 2, and multiply this by 2. I end up with 8 is greater than 0. Still a true statement, right? Okay. If I took the exact same inequality, though, and I multiplied by a negative 2 on both sides, then I end up with a negative 8 is greater than 0. Uh-oh, that's not true. If you multiply or divide both sides of an inequality when solving by a negative number, the inequality sign has to flip over in order for it to remain true. Okay, that's very, very important for you to know. So put that in your notes and make sure you get that into your memory, because that is a very important thing, and that would mess you up if you multiply or divide by negative and you don't flip it. Okay, so now let's graph. My point is negative 1 for my intercept, and I have a slope of 3 over 2. So I'm going to go up 3 to the right 2, up 3 to the right 2, and I don't want to go that far up, so I'm going to go down 3 and to the left 2. Now, this sign doesn't have the little equal part, so I got to make it dashed like this. Now, when it comes to shading, I want to look at this one here. It's a less than, so I bet the shading is going to be down here. But let's check. So I'm going to pick my point 0, 0 because the line doesn't go through it. When I do that, though, I have to use the original inequality. So 3 times 0 minus 2 times 0 should be greater than 2 if 0, 0 is on the correct side. This all becomes 0. I have 0 is greater than 2. This is false. And sure enough, this region down here is my solution, or where my solutions lie. Okay? Not too bad? All right, I want you to try one more, and then we're done. So go ahead and try this one, please. Pause the video. Okay, to get rid of this x, you would add x to both sides. This would leave 2y here is less than or equal to x plus 6. Then we're going to divide every term by 2, and I get y is less than or equal to, now, I'm going to rewrite this as 1/2 x plus 3. And again, you could do that because if I were to multiply this x times 1/2, it would just end up in the numerator anyway. My intercept is 3. My slope is 1 over 2. That means I go up 1 over 2, up 1 over 2, up 1 over 2, or down 1, back 2, down 1, back 2. It is less than or equal to, so I'm going to be a solid line. Less than is going to be down here, so I bet you if I pick 0, it would give me a true statement. So let me try that. Negative 0. You know there's no such thing there. Okay, just want to make sure. The negative's on the outside, though. Times 0 here is less than or equal to 6. This all becomes 0. 0 is less than or equal to 6. And so this point is a solution. And that means that I would fill in that area. Okay? Not too bad. That is all. Goodbye. Just don't forget about that flipping the inequality. That's huge. Goodbye.